let's apply the standard production rate, daily standard production rate P, and actual equipment productivity in problem 4, and then problem 5. So problem 4, a power salvo with a dipper. You see the bucket 1 loose cubic yard capacity had a standard operating cycle T of 30 seconds. And the question is determine the daily standard production rate, and also determine the job site productivity and the actual cycle time of this salvo under the work condition that have effect 4 factor that we have it in here. So with that, we can apply the equation above to show this two components for these problems. First, daily standard production rate. Standard production rate. And from what we learned in here, the daily standard production rate equal to P RH or CH over T. So we have that equal to P equal to RH and R equal to C over T times H, as you can see there. So let's find out the what is the R. So C over T, right? So we have R equal to C over T. What is C? Cycle capacity in this one is 1 loose cubic yard. So we have C equal to 1 LCY. Divide by the cycle time, 30 seconds. So we have 30 seconds. But we want to change that standard standard production rate per hours. So you can convert that into per hour. So we have to time the numerator by 3600 second per hour. So with that conversion, we can get the standard production rate R equal to 120 loose cubic yard per hour. So unit conversion is very important. And if we assume H, the number of hours operating per shift is 8 hours per day, so we can have the P equal to R times H, as you can see there. So 120 times 8 hours per day. So as you can see in terms of the unit, let me do that one here, LCY per hour time 8 hours per day. So we have the units is LCY per day, and 120 times 8, 960 loose cubic yard per day. What does that mean? This salvo can produce with the daily standard production rate of 960 LCY per day. And now the question have the job site productivity, which is the actual productivity and the actual cycle time, because it may be slower than the standard cycle time. So with factor, for example, bug composition, reducing soil property and water content different from the standard that we have to adjust. Equipment idle time for the worker practice lower than standard, so it adjusts. Efficiency also lower compared to standard in terms of management, supervision, etc. So we have to adjust it. So from that we can have a B, job site productivity or actual productivity, right? Productive for this machine, and the actual cycle time. And whenever the actual I mentioned earlier, it will be apostrophe. So that one here, the apostrophe. So in terms of the job site productivity, we have the job site So it will be P apostrophe that we have here, and then we adjust for all the factors. If we say about hours, then R apostrophe. If we talk about the dailies, then P apostrophe. So it will be P time F1, F2, F3, and then F4. We have 4 of them. So we just plug in with the adjustment P 960 LCY per day time F1. F1 in this case is 0.954. Then we have 0.954. Plug in. (954) F2 0.983, F3 0.8 and 0.7. So we get only 504 LCY per day. So that the actual productivity almost only half of the manufacturer claim production. So as you can see, the way that we have to manage, control the operation is very important. That will affect the productivity of the project. And then the second is the actual cycle time. So how can we determine that? There are 2 ways that we can determine here. Actual cycle time. So the first equation that you can use is get T apostrophe, the actual. So you get T just divided by all the products of F1, F2, F3, F4, and T, as you can see, 30 seconds. That is standard cycle time, 30 seconds. The problem given, 30 seconds. And divide by all of that number, 0.954, 0.983, 0.8, and then 0.7. So we get 57 seconds. So what does that mean? One cycle is almost double of the standard cycle. That's why we have expected the lower productivity than standard. Or alternatively, we can use this equation to determine the actual cycle time. That is T apostrophe, just basically equal to cycle capacity divided by the R actual productivities. Okay, so with the R, you apply from that equation here, R apostrophe, and C in this case, 1 loose cubic yard, you can be able to find out the apostrophe, and that your task. You need to check whether we get you get 57 seconds. So in the next one, we will do the problem 5.